To identify the real zeros of a polynomial function, we could actually make use of the Descartes' law of sign. So what does it says? When we are trying to use Descartes, let me just write that, the Descartes' rule of sign. According to Descartes, we can actually find the real zeros, the number of real zeros of any polynomial function by just looking at the change of sign. So for example, if we want to know the number of the positive real zeros, what we can do is just write the function and then count the change of sign. So for example, our first term is positive and then the next term is a negative. So there are how many change of sign? There is actually 1. So from this test, we can actually say that we have 1 positive real zero. Now what about the negative? So again, according to Descartes, when we want to find the negative real zero of a polynomial function, what we can do is change every x to negative. So we will do x cubed minus x squared. So again, change every x to negative x. So this will become negative x cubed. And then we have minus negative x squared. If you're going to simplify this, this is just negative x cubed and then minus x squared. And then again, the same with the positive real zero, we're going to count the change of sign. So we have negative and then negative. So we don't have any change of sign, so we can actually say that we have 0 negative roots. So again, we have 1 positive real root and then 0 negative real roots. But if we're going to look at our equation or our function, we can actually make use 0 here, right? When we do 0 cubed minus 0 squared, this is actually equal to 0. So 0 is considered as our real roots. Remember, in our real number system, 0 is part of, again, our real number system. So when we try to answer this question, state the actual number of real zeros, we can actually have, the answer should be 2. Alright? So 1 positive and then the other one is 0. What about number 6? So again, using Descartes' rule of sign, I'm gonna do x to the 4th minus 4x squared plus 2. And again, we have positive, I have negative, and then I have positive. So I have 1 change of sign, 2 change of sign. So I have here 2 positive real zeros. What about the negative zeros? So I'm gonna do x to the 4th power minus 4x squared plus 2. And again, this will become negative x to the 4th minus 4 negative x squared plus 2. When I simplify this, this is just positive. And this is positive, but times negative, that is negative 4x plus 2. And again, I have positive, I have negative, I have positive, I have 1, then I have 2. So the answer to this is actually, I will have 4 real zeros. Alright? So again, remember, the degree actually will tell us the maximum number of roots that we can have from a given polynomial. So in this example, we have 4. So we have 2 of that is positive, and then the 2 of that will be 2 negative real roots. Number 7. What about this one? So again, using Descartes' law of signs, we're gonna do, for the positive root, we're gonna have x squared plus 8x minus 12. So again, I have negative, I have positive, and I have negative. So change of sign, I have 1 and then 2. So I have two positive real roots. I don't need to check for negative because again this is a quadratic function, and then again I've reached my maximum. But if you want to make sure, you can actually do that. But again, I am telling you that the answer to this is a 0. We will not have a negative real roots. But again, we'll try. X squared plus 8x minus 12. And then again, this will become negative of the negative x squared plus 8, then negative, and then 12. So simplify, this is just negative x squared minus 8x minus 12. So again, I have negative, negative, negative. 0 negative roots. Because again, we actually hit our maximum number of roots. That is 2. So again, we have here 2 real roots. And again, the 2 of them are actually positive. What about number 3? So again, let's look for the positive roots. Positive roots. And then again, remember, again, the maximum is 3. Alright, max is 3. So we're gonna do x squared, a cube, minus 3x squared plus 3. So I have positive, I have negative, I have positive. So I have 1, and then I have 2. So I have 2 of this, 2 positive roots. What about the negative one? I'm gonna do x squared, x cubed, 3x squared plus 3. And then again, change every x by a negative 1. So I'm gonna do negative x cubed minus 3 of the negative x squared plus 3. And then when I simplify, this will give me negative x. And then this is positive, right? Positive. But multiply to negative, that's negative 3x plus 3. So I have negative, negative, plus. So I have here 1 negative root. So in total, I have 3 real roots. 2 of that is positive, and then 1 of that is actually negative. So to show that our answer is actually correct, let's try to plot this using our tool, GeoGebra. Where is my GeoGebra? Alright. So I have here x cubed minus x squared. And then I have x to the 4th power minus 4x to the 2nd power, or x squared. And then plus 2. Then I will have the other one. We have negative x squared plus 8x minus 12. Then the last one will be x cubed minus 3x squared plus 3. Okay, so let's start with the first one. Let's start with x cubed minus x squared. So again, we said that we have 2 real roots, right? One is 0, and then the other one is actually a positive root. We don't know what is that, but then again, we know that that is positive. So if we're going to look at our graph, alright, we have 0, and then we actually have, let me just do special points. Alright, so we have this one. The roots are this. We have 0 and a positive 1. So again, it coincides with our answer earlier that we have a 0 and 1 positive root. So we have a total of 2 real roots, or real zeros. What about number 6? We said that we have 4 real zeros. 2 of that is positive, and then the other 2 is negative. Let's try to check. Alright. So as you can see here, let me just hide this. As you can see here, special points. Look, we actually have 4 roots, right? This one, 2 negatives, and then 2 positive. Again, it coincides with our answer here. 2 positive real zeros and then 2 negative real zeros. What about number 7? We said we have 2 real roots. Both of them are positive. So let's try. Both of them are positive. Let me just hide everything. Alright. This will be our graph. And then look, we actually have, again, our roots. This one. 2 and 6. No negative roots. Okay? And then for the last one, we said that we have 3 real roots. 2 are positive and then 1 is negative. So let's try to check if that is actually correct. Let me just hide this. Alright, let's go back here. Again, 2 positive and then 1 negative. And then this will be our roots. Oops, what happened? Wait, I think there's a misclick. Okay, special points. So again, our roots is this. We have 2 positive and then 1 negative. So again, that simply means that our answer, our approach is actually correct.